In this video, we are going to learn first how to find angle between two vectors. Then we'll learn about null vector, unit vector, rectangular coordinate system, and then how to find components of a vector. First, let us learn how to find angle between two vectors. Say this is one A vector and this is another vector B vector, and the angle between them is 60 degrees like this. This is some other A vector and B vector says like this, and this angle is 120 degrees. This is some A vector again, this is B vector, and angle is 300 degrees. So now if I ask you, what are the angles between the vectors in the three cases? First case you will say 60 degrees, second case you will say 120 degrees, and third case you will say 300 degrees. But look carefully, this A vector, and this A vector are all parallel and they have the same length, so they are the same vectors. This B vector, and this B vector are parallel and equal, so they are the same vectors. So therefore, the angle between them must be same. The angle between the vectors in all the three cases is 60 degrees. How do you find that? We bring the tails together and then look at the smaller angle. In this case, the tails are together. Smaller angle is 60 degrees. So angle is 60 degrees, no problem. Here you have to shift this B vector here. Then only the tails will come together. And now the smaller angle is again 60 degrees. Here you shift this B vector from here to here so that the tails are together. And again the smaller angle is 60 degrees. So this is how we get the angle between two vectors. To find the angle between two vectors, the tails must be brought together. The smaller angle then gives the angle between the two vectors. The other way of finding this angle is, you look at the direction. This A vector is in this direction, this B in this direction, and the angle between the direction is 60 degrees. Same way, here you see A vector is actually in that direction and B vector is in this direction. Angle is 60 degrees. Here you see A is like this, B is like this, and the angle again is 60 degrees. So in all cases, the angle between the two vectors is 60 degrees. Now we will learn about null vector. Null vector is also known as zero vector. So 0 with arrow on top, or write the Greek alphabet phi. So how will you get a null vector? How do you get 0? 2 minus 2 is 0. So A vector minus A vector is null vector. Null vector has got a magnitude of 0. That's very obvious. And what is its direction? Direction is arbitrary. We cannot assign any direction. Suppose I say I move 0 meters. Then you cannot ask me in which direction. So direction is indeterminate. We cannot find the direction. So direction of a null vector is indeterminate. Magnitude is 0. Now what is a unit vector? Unit means, no, not that unit. Unit here means 1. A unit vector has got a magnitude of exactly 1. And it points in a particular direction. Its only purpose is to specify the direction. It has got no dimension or unit. No unit like meter, centimeter, meter per second, or anything like that. A unit vector only job is to specify the direction. We follow a right-handed coordinate system. Say this is the x-axis. Perpendicular to this is y-axis. All of you know that. There is one more axis that is perpendicular to both x and y axis. That is called z axis. How to get the direction of positive z axis? Take your right hand. If you write with your right hand, keep your pen down and take your right hand. Right? Otherwise you'll be tempted to take your left hand. Your fingers should be able to move from positive x to positive y axis. So now my fingers can easily move from positive x to positive y axis. If I keep like this, my fingers cannot move from positive x to positive y axis. So to keep my hand like this. If your fingers can easily move from positive x to positive y axis, the outstretched thumb gives the direction of positive z axis. And this z axis is perpendicular and out of the board towards you. But we cannot draw it like that. So we draw it like this. The angle between this x and y axis is 90 degrees. What is this angle? No, not 120. It is again 90 degrees. Z axis is like that, not like this. And what is this angle? This is also 90 degrees. Now in this right-handed rectangular coordinate system, to specify the x direction, we use a unit vector. And that unit vector is called I cap. Some people call it I hat. Some people call it I caret, that is caret symbol. Some people call it I roof. Okay, if you draw a hut, the roof will look like that. Whatever way you call it, you always write it like this, I cap. J cap is the unit vector along y axis and k cap is the unit vector along z axis. These are standards. Some people use x cap, y cap and z cap for these unit vectors, but most people use I cap, j cap and k cap for these unit vectors. Suppose a particle has a displacement of 5 meter along x axis. So instead of saying so much, we can just say the displacement of the particle is 5 I cap. So when you say 5 I cap, everyone knows that the displacement is 5 units in the x direction. Same way, if a particle has a displacement of 2 j cap, then everyone knows the particle has moved along y axis. If you say 3 k cap, then we know that the particle has moved along z axis. So this I cap, j cap, k cap are telling us the directions. Suppose a particle has a displacement of 5 I cap plus 2 j cap. That means the particle has moved in this direction, in the vector sum of 5 I cap and 2 j cap. So these are the 3 unit vectors along the x, y and z axis. Now we learn components of a vector. Suppose you have moved from O to A. This is east direction, this is north direction. So by going from O to A, how much east have you moved? We'll drop a perpendicular from here and you have moved this much east. And how much north have you moved? We'll drop a perpendicular from here and this is the distance you have moved north. You have neither moved north nor east. You have moved northeast. But this O to A is equivalent to so much in the east direction and so much in the north direction. This is the meaning of components of a vector. Suppose you have got this as the x-axis, this as y-axis, and there is a vector from here to here, O to A, say A vector. This A vector is equivalent to this much along x-axis plus this much along y-axis. This is called x component of A vector A subscript x, and this is called y component of A vector A subscript y. This is A vector having a magnitude of A. Let us say it makes an angle of theta with the x-axis. This A vector is equivalent to Ax along x-axis, Ay along y-axis. So we can say A vector is Axi cap plus Ay j cap. Now how to find Ax and Ay? We know A and theta. How to find Ax, Ay? Look at this triangle. What will be cos theta? Adjacent side by hypotenuse, right? So what is Ax? Ax is A cos theta. This is the x component of A vector. How much is this angle? 90 minus theta. Now look at this triangle. What is cos of 90 minus theta? It is sin theta, I know, but what is that in that triangle? Adjacent side here now is Ay and the hypotenuse is A. So Ay becomes A sin theta. So therefore, A vector is Axi cap plus Ay j cap, where Ax is A cos theta and Ay is A sin theta. Now why did we write cos here? That is to understand that the component of a vector in any direction is equal to magnitude of vector multiplied by cos of the angle between the vector and the direction. This component is equal to this vector magnitude A multiplied by cos of this angle. This component is A into cos of this angle. This is how we find the component of a vector in any direction. In two-dimensional case, one component becomes sine component, other component becomes cos component. The component in the direction of known angle is cos component. The component in the direction of unknown angle is sine component. Let us try to understand this. If this is x-axis, this is y-axis, and this is some p vector. This p vector makes an angle alpha with the x-axis, say. So then the x component of p will be p cos alpha. This is the component direction of known angle. The y component of p will be p sin alpha because that is the component in the direction of unknown angle. Suppose this is x-axis, this is y-axis, and we have got a q vector like that. And this angle makes an angle beta with the y-axis now, not with the x-axis. So what is the x component? This angle we don't know. So this becomes sine component. And what is the y component? We know that angle. So it is cos component. So this way we can find the component of a vector in two-dimensional case. We cannot apply this in 3D case. In three-dimensional case, always we say that the component of a vector in any direction is equal to magnitude of vector multiplied by cos of angle between vector and direction. Now suppose Ax and Ay are known. How do you find A? Right? Simple Pythagoras theorem. A will be how much? Root over Ax square plus Ay square. And how to find this theta? Tan of theta will be Ay upon Ax. Any vector can be expressed in two ways. First is magnitude angle, A and theta. Second is in terms of components. So in a two-dimensional case, we'll have two components, Ax, Ay. So we can easily move from A theta to Ax, Ay. If A theta is given, how to find Ax, Ay? Ax will be A cos theta, Ay will be A sin theta. Typically, theta is the angle between the vector and the x-axis. So Ax is A cos theta, Ay is A sin theta. If Ax, Ay is given, we can find A theta. So say Ax, Ay is given to us. How to find A theta? A we got from Pythagoras theorem. So A is root over Ax square plus Ay square, and tan theta will be ay upon ax. Right? This was our x-axis, y-axis, a vector, theta, this was ax, this was ay, this is a, this is also ay. So you can easily see all these relationship in that simple diagram. So this is how we find components of a vector in two-dimensional case. In general, a vector will have three components. A vector will be ax I cap plus ay j cap plus az k cap. Ax, ay, az are the components of a vector. If we apply Pythagoras theorem twice, we can easily show that magnitude of a vector, that we can write like this, or just the alphabet A, will be equal to root over ax square plus ay square plus az square. Now how to find a unit vector in the direction of a vector? What is unit vector? We discussed that earlier. A vector by its magnitude will give us a unit vector. Unit vector has got a magnitude of exactly 1. So that we write as a cap. A cap will be a vector by magnitude of a vector. A vector is ax I cap plus ay j cap plus az k cap by root over ax square plus ay square plus az square. Can you tell me why these coordinate axes are perpendicular to each other? Why is the x-axis perpendicular to y-axis and z-axis? Why is y-axis perpendicular to x and z? And z perpendicular to x and y? Let's try to understand this. This is x-axis. This is y-axis. Right? If a vector is there along x-axis, this is the a vector. What is the y component of this vector? The y component of this vector will be a cos 90 degrees. Right? Magnitude into cos of the angle between the vector and the direction. And that is 0. So this a vector, which is along x-axis, has no component, has 0 component along y-axis. Same if a b vector is along y-axis, the x component of b will be b cos 90 degrees. That is 0. This is the reason why the coordinate axes are perpendicular to each other. That way the components become independent of each other. The x component is independent of y and z component. The y component is independent of x and z component. And z component is independent of x and y component. And that way we can study motion or anything else along each axis independently. When looking at x-axis, we need to look only at x-axis. When looking at y-axis, we need to look only at y-axis. When looking at z-axis, we need to look only at z-axis. The components are independent of each other. And once we understand this, adding and subtracting vectors using components becomes very easy. Say a vector is ax I cap plus ay j cap plus az k cap, and b vector is bx I cap plus by j cap plus bz k cap. Suppose you have to add them. Then you can add the x components independently, independent of y and z. So we'll get ax plus bx I cap. We can add the y components independently, ay plus by j cap plus az plus bz k cap. So components can be added independently. And same way we can subtract. There's a plus sign. If you put a minus sign, addition becomes subtraction. Now adding and subtracting vectors using components is very easy. A vector is say 2i cap plus 3j cap, and B vector is I cap plus j cap. So what will be A vector plus B vector? Just add the x components, 3I cap, just add the y components, 4j cap. And what will be A vector minus B vector? 2 minus 1 I cap, 3 minus 1 2j cap. So adding and subtracting vectors using components is very easy. The components are independent of each other. Now let us see whether we can rotate a coordinate system. All this while we have been taking this as the x-axis and this as the y-axis, and say this is a vector, A vector. Suppose I don't like this x-axis. I want to call this as the x-axis. Can I do that? Yes, I can do that. Then perpendicular to this will be my new y-axis. Now what will happen to the vector? Earlier this A vector was making some angle theta with the x-axis, say. So what will happen to this vector? Will the vector rotate? No, the vector will not rotate. We can rotate the coordinate system, but not the vector. Please remember that. A vector points in a particular direction. That direction cannot change. X and y axis can rotate. So we can rotate the coordinate axis, but not the vector. Now this vector will make an angle alpha with the new x-axis. Therefore, the components will change. Is that okay? Yes, that is okay. We can rotate the coordinate system, but not the vector. In this way, we can get infinite number of components, and all are correct. Laws of physics do not depend on the choice of coordinate system. Therefore, we have freedom in choosing a coordinate system. We can take anything as x-axis, perpendicular to that as y-axis, and perpendicular to these two as z-axis. Right? What happens when a vector is in the 3D space? Let us look at that. This is some x-axis. Perpendicular to this is y-axis. And z-axis is perpendicular to both these axes. Now this p vector is not on the xy plane. P vector is in the 3D space. So this p vector, same angle alpha with the x-axis, beta with the y-axis, and gamma with the z-axis. Please understand that the vector is in 3D space. So alpha plus beta is not 90 degrees here. Vector is not sleeping on the board like this, but vector is in the 3D space. Therefore, alpha, beta and gamma are not directly related that way. Alpha plus beta is not 90 degrees. Now I want to find the relationship between alpha, beta, gamma. How are they related? So this is, say, O, this is P, and this vector is, say, P vector, magnitude is P. So what is the x component of P? To find any component, multiply the magnitude with the cos of the angle between the vector and the direction. So Px will be equal to P into cos of the angle between P vector and x-axis. How much is that? Alpha. So P cos alpha. What will be Py? No, not P sin alpha. It is P cos beta. That sin cos is valid only for 2D case. Now this is 3-dimensional space. So that relationship does not work. Remember, alpha plus beta here is not 90 degrees. It may look in the diagram, but actually it is not 90 degrees. So Py will be P cos beta. What will be Pz? Right, it is P cos gamma, that's simple. So now this P vector is equal to Px I cap plus Py j cap plus Pz k cap. Right? So what is P equal to? We have seen magnitude of a vector. So P will be root over Px square plus Py square plus Pz squared. So P is root over Px square plus Py square plus Pz square. Now we don't like this square root sign. So we can take square of both sides. Right? P square. Px is P cos alpha. Square that. We get P square cos square alpha. Then plus P square cos square beta. And then P square cos square gamma. This is gamma. Right? So now we can take P square common. P square by P square will give us 1. So from here we get a very important relationship that cos square alpha plus cos square beta plus cos square gamma is equal to 1. These cos alpha, cos beta and cos gamma are called direction cosines of P vector. If we say cos alpha is L, cos beta is M and cos gamma is N, L square plus M square plus N square will be equal to 1. This is a very important result. Now suppose somebody asks you a question. Some vector, say P vector again, makes equal angles with the x, y and z axis. And they ask you what is the x component of that vector. So how to find that? If it is making equal angles with all the three axes, what does it mean? It means alpha is same as beta is same as gamma. L is equal to M equal to N. So all will be same. Now we know L square plus M square plus N square is equal to 1. So from here we get 3L square equal to 1. L becomes 1 by root 3. And what is L? L is nothing but cos alpha. So cos alpha is 1 by root 3. So from here we realize that Px will be equal to P cos alpha will be equal to P by root 3. So that is as simple as that. So remember, L square plus M square plus N square is equal to 1. Sum of these squares of the direction cosines is equal to 1. Thank you.